Hi, everybody. My name's Galvin. I'm the CEO and co-founder of Loretta AI. And today, before I go into the technology, maybe a little bit of a kind of a thought process on what we're doing here. And so Loretta AI is a company built around a question of if a person is in the space, is it a question of what they are doing or why they are doing what they are doing that really matters? And so Loretta AI is essentially a behavioral AI company to kind of infer the intent of an individual in space. And then once you can infer the intent, you can decide whether when they do something, is it an alert or it's not. And that's kind of the basis of it. And one of the questions that we ask ourselves is, if your AI is like 99% accurate and so many AI algorithms right now have really high numbers on what is going on in a frame, why is it that we trust the security guard that is sitting there looking at 50 cameras at the same time? And if I was to give it a single word answer, the answer would be time. That they have the intuition to observe those things that matter longer and more precisely, so that when they say that something's happening, it's probably because it's happening, right? And so, so this is a company we founded in 2020, and I want to thank the SVIP team right now because at that point in time, we didn't have a physical presence in the US, and we're one of the few facilities that allows a company like that to operate and work with the government. And now we do, and now we are up in Austin. We work with two different groups, with the screening at speed team, where we talk about self-service screening, where we ask the question of, if you never talk to a TSA agent, does it matter? He does, right? And then there's also with the soft targets team, right? And let me just share a little bit of the things that kind of builds it together. The very first is the ability to identify a person from any direction in any place, so non-biometrically. Attribute things to those people, and then also attribute the association they have with other people. What that allows us to do is that, for example, in an active shooter situation, rather than say that my algorithm is 2% better, what I can say is that I've observed the person with a gun more than 100 different times before we trigger an alert. It also means that if a bag is left behind in a busy place where everybody has stuff, we can also say that that is a bag that is not left with her friends or beside or elsewhere, but done accidentally or deliberately. By doing that, we can not only allocate risks and threats, but also then position them in space and then know exactly where threatening people are, right? And because this algorithm is built over a number of years with both DHS as well as military people, the system is designed to be extremely robust to day and night environments. And so, this is essentially what it is. So the very first and most fundamental technology that has to work is that we have to be able to pick out a person and re-ID that person across every camera. And for better or for worse, because half of our entity was initially in Singapore, we were asked to find a single person wearing pink in a place where everybody was wearing pink. And so in this one 3-megapixel camera with 25,000 people in it, there is a guy named Bob. And if you look very carefully, you will find an image of the guy named Bob in the top right corner. It has an accuracy of 1, which means we always find the guy, and we have a false positive of 0.67, which means we made 1 mistake. So we found 2 guys, and one of them was Bob. And we have an ID for every single one of the 25,000 people in space. So this is kind of the base of the system. The system then allows us to build a knowledge graph of all the things that happen in the space and use that context to make decisions on whether stuff is going the right way or not. Thank you. That allows us to then essentially take the same algorithms in terms of the quality, and by using time, we cut the likelihood of having a false positive by between 10 to 50 times. And this allows us to build autonomous systems that, for example, in the case of Singapore, the decision was made to remove the human in the loop, where the alert goes directly to the person on the ground. With Homeland Security and with the SVIP team, you can see it happen in 2 different places. One with self-service screening, where the agent is what makes sure you put your stuff in the right bag, and you take your own stuff at the end of it and scares you into not trying to cheat the system, which is very important, without actually opening his mouth, right, just by being there and being scary. And with soft targets, where we work together with different NVL systems to allow us to essentially build into the existing workflows and do exactly the same thing, but with such a decrease in false positive that you can actually build the system directly and then build workflows directly out of those systems. What's next? This allows us to build things that work with novel technologies. One of the things that we do is we also detect things that are not in our data sets. It allows us to then work with different teams that have now allowed us to integrate these things together with the LRBA that we are currently in the process of being selected and negotiating, and also productioning it in different places. Our system is now deployed in Dallas, and previously with the TSA's Innovation Task Force program in Las Vegas as well. Thank you very much.
Great presentation, and very helpful, and obviously appreciate the partnership with TSA. I think it was on your last slide, you mentioned identifying things in bags that don't normally be in bags. Could you provide a little more context about what that's about?
So one of the things that we built is the ability to identify a thing that was not in your data set. So if your data set has a screwdriver and a hammer, it will say that I have a tool, an unfamiliar tool is on my table. So we'll know it's a tool-ish. Okay, that's not always true, but it kind of knows it's a tool, but it knows that it's completely novel. And the technology behind that is something called a diffusion autoencoder. Essentially, it's like stable diffusions generation, but fast. That's kind of how it works. Yeah.
Great job. Thank you. Can you talk a little bit about how you generate the knowledge graph, how you characterize the completeness of the knowledge graph, if that's important to you, and talk to the possibility of integrating other sensors for different modes of data into this for improved models?
So yeah, thank you for that. So let me answer those two questions separately. So around the knowledge graph, I think the first important thing is that if you want to build a complete knowledge graph, at least one of your data points has to be sufficiently complete that you know that everything else is kind of lacking. And the one for us in that particular case is human detection. So human detection algorithms that count people from up to 50 feet is almost solved, essentially. It's like 99-ish% accurate. It's better than the guy doing this at the counter, right? So it's good enough that it's close to perfect. And so you use that as a base. And then the three things that we connect to it, one is the continuity of the identifier. So essentially the same person gets identified. The second thing is your possessions. So things that are seen, held and owned by you at some point will be attributed to you, so that if, for example, I take my bag and I give it to my wife, it doesn't say it's my wife's bag. It says that Galvin's bag has been given to his wife. Okay, so that's that component of it. And third one is around associations. And now one of the important things is that our associations are ephemeral. That means if me and my wife are not talking, and we go to the mall together, it will say that we are not together. Which is how it feels. But in real life, the system is designed to build up ephemeral connections so that if, for example, I play fight with my brother, it is not something that the police need to go and check out. On the second question, which is around connection of IoT systems, once multiple systems get connected, the IoT layer or the integration layer has to be very enterprise grade. Now, with the project that we do at TSA, we do that ourselves. So we run through all of the systems and it's run as a screening integration layer. But that's a bad idea in general. The right way to do it would be an IoT intermediate platform where everything connects into, and that's where you can command and control your open standards and so on through that. And that's what we did with the TSA in our first contract. So in that case, for example, we use ThingWorx as the integration layer. So what we did is that every single system only provides the metadata, right? So the body scanner just says body scanner with session ID, at time. And then at that point in time, we will connect the person that went in is the guy who scanned there. And so the data set that you have has a person-centric view, right? This person scanned this, and this. In that case, there was also an interface. In that case, Vondelon, they provided a unified interface that's currently available in the innovation checkpoint that integrated pieces together. Yeah.
Okay, and then as you're going through, you started with that you were that you had some sort of intent behind
Yes.
what was happening. So your inference is that when you gave your wife the bag, that is a flag for intent, and then that gets flagged in the system?
So then what will happen is that when the bag gets transferred to my wife and then it gets separated from me, there is a bag abandonment trigger. The trigger gets
Okay.
created and then it gets suppressed by the fact that it's still connected to one of the people that is friendly with me, and so it gets suppressed that way.
Okay, okay, and then that would work in the large scale because you have the nodes in your essentially graph database that
Yes, correct.
that are linking them together, and so if those are actually linked together nodes, that gets suppressed. But if they're not linked together nodes, then it would
Correct.
flag for someone to immediately go and figure out what's going on.
Correct. And so
Okay.
just to connect with, for example, what Steve mentioned a while ago, most of our contracts end up in the 10 to 300 camera range. We don't go up to 500, but it doesn't really work when you have only 2 cameras because the re-identification is what allows us to have very strong identity IDs of people. That helps. That's kind of what links all the data together.
Do I have time for that? And then is it in the 10 to, I think you said 10 to, sorry.
10
what?
to 300.
10 to
Right now it's
300
yeah.
camera range. Is it helpful if there's like a start and stop of the thing? Or if it's like a concert where there is lots of people,
So we've
lots
done-
of times, but
we've done
start and stop?
concerts. We've done concerts. It's a bit, so what tends to work is that if you have cameras that cover the inputs and outputs, you can control the population. And that helps a lot.
Yeah, okay.
Yeah. All right, yeah, thank you so much.
Okay, great. Thanks, Galvin.